Hello everyone. Welcome to this talk. It will be a game, so yeah, please welcome. I made this talk with my friend. My name is Anton Dudakov. We made it with my friend and colleague Vladimir Merkuryev, but he was not able to attend here today, so I will do it by myself. So, as I said, I'm Anton Dudakov. I live in Dubai. I work in financial startup called Zina, and I'm mostly experienced in Android, but since it's a startup, I do many things, and backend and iOS as well. Previously, I was working mostly in system development with firmware and things like this. Also, sometimes I do talks and organize some meetups in Dubai. Yeah, what we will do today, please take your phones, scan this QR code. It will open a quiz. This will be a quiz, as I said. This will be a game. I will be showing you the code, and I will be asking questions. What will be on the screen? Okay, yeah, I will be showing the code and asking questions, and you will be answering them. No prizes, no winners, it will be everything just for yourself. You will see how many times you answer correct or not. And yeah, and this is everything just for fun and sometimes for education, because each case we will discuss, or I will tell you what just happened. And everyone joined? All good? We can continue? Yeah, let's go. And let's start with the first. Please enter your name. I started the quiz, so you can join. Oh, how many? A lot. And let's start with the first case. So, here's the code. We have two coroutines. We launch them. And what will be on the screen? Please answer. Okay, nice. 5 more seconds, and I'll pause and run. 5, 4, 3, 2, 1. And let's run. CAB. And what did just happen? Why like this? So from the main coroutine, we launch two of them. We launch first, it got suspended, and the control went to the main coroutine. And we launched the second, and it got suspended on the delay. And the control went back to the main coroutine. Main coroutine prints C, then first coroutine unsuspends prints A, and then the second. That's it. And the next case, scope number 2. What will be here? Oh, you're already answering. So something changed. There's something new, but what exactly? Try to guess or try to find out. What will happen? What this code will print? Okay, 5 more seconds. 5, 4, 3, 2, 1. And stop and run here. ABC, just straightforward. And what happened? Why ABC? Yeah, so in the main coroutine, why like this? Because coroutine scope is a suspend function, and when we launch it means that it suspends and it waits. And stop. From the main coroutine, we launch job A. It runs, it suspends, and then the control goes back to main function. It runs the coroutine, which delays and control goes back to the job A, because the thread is free to launch anything. It brings A, and then control goes back to the coroutine scope, which prints B, and once it's finished, the main coroutine unsuspends and prints C. Okay, the next bunch of tasks is how should we work with the cancellation. And show me the code. Number 1. What will be on the screen? What will we have here? So what do we have? We launch a coroutine with a loop inside of it, and what's going to happen? We delay, we cancel the launched coroutine, and what will be on the screen? Little bit harder than the previous one. Okay, let's answer. 5 more seconds. 5, 4, 3, 2, 1, and let's run. A012 CBD. CBD. And why? What did just happen? So, first of all, we need to know that the cancel and join is a suspend function. It means that it got suspended and it waits for the job to really stop, to cancel. And once we call it, we have a cancellation exception. And this cancellation, once we have this cancellation exception, since we have it in the try catch, we print B. And then, of course, it finishes, it unsuspends, and then we print D. So that's it. The next one, cancellation number 2. What will be on the screen? So here we have something new, something called supervisor job. We launch a coroutine, we print A, we have a delay, almost infinite delay. In which order it will be printed? I forget to say that sometimes I will try to mix you and make things much harder. There will be some tricks. Okay. 5, 4, 3, 2, 1, and stop. And let's run. A, C, D, B. Why? So first of all, we launch a coroutine, and it's with it. It's not with context. It's just with it. It's another thing. It's a trick. So it's not like we launch a coroutine. It's just another thing. So. Yeah, and we print A, then we have a delay, this infinite delay, and since delay it's a suspend function, the control goes back to the main coroutine, which prints C, and then it cancels the job. And this cancel is not a suspend function. It's not cancel a join. It's just cancel, and it just calls cancel and goes to the next. Because it's a same thread, it cancels coroutine and prints D. And then when the thread is free to launch the next one, it prints B. Okay, how do we handle exceptions? The next bunch of tasks and tricks. So what we have here is, let me switch. Number one, what we have here, we have an exception handler, and we launch a coroutine with an exception handler. Inside it, we launch two child coroutines, two child tasks. And what's going to happen? And the main question is, will we have a lollipop in the end? Will we? Yeah, you see this this nice emoji of the blow. So yeah, it prints, the coroutine handler prints the or exception handler prints this nice emoji. So this is why it's here. Okay, we don't have a lot of time, so just 40 minutes. So 5, 4, 3, 2, 1. And let's run. A, C, B, and then crash. Exception. No lollipop. No lollipop this time, but what did just happen? So first of all, on the main coroutine, we launch the child one. This child one suspends and waits for the next. And then, since it's suspended, the control goes back to the job. Job launches the second child, it prints C and suspends. Then the control goes back to the to something else, and once the delay finished on the child one, it prints B, and then it throws an exception. The exception got handled by the parent job, and it got propagated to all children. So they all canceled, and this is why we don't have lollipop, because they all canceled and it doesn't go next. So that's it. Yeah, it's propagated to all children. But how not to fail? How not to propagate the exception to all children? There is a nice thing. There is a supervisor job. If we will use supervisor job, then our children can fail independently. And let's try. Let's try to do it. Exception number 3. Yeah, we don't have 2 because with all my cases, this talk could take more than an hour. So I removed some of them. What will be on the screen? So we have a supervisor job. We create a new scope with a supervisor job, and we use this scope, and we launch coroutine on this scope with an exception handler. What will be on the screen? And my main question is, will we have a lollipop? How do you think? Okay. Okay. Oh, much faster than the previous question. 5, 4, 3, 2, and let's run. No lollipop. No lollipop at all. But why? So, yeah, we are using a supervisor job, but why there is no lollipop? Why we didn't have it? So it means that the exception propagated to all children, so they all got cancelled. Maybe we do it wrong. let's try another way. And the next exceptions, number 5. Let's try this thing. So this scope is just job, and we use this nice DSL supervisor scope. And inside the supervisor scope, we launch two coroutines. Will we have a lollipop? And again, we throw an exception. No tricks here. Maybe. Okay. Nice. Will we have a lollipop? And 5, 4, 3, 2, 1, and let's run. Yeah, we have it. So our supervisor scope helped. So we have it, all good. And why did it help? Because supervisor scope created a scope with the supervisor job, and this, in this context, is a coroutine scope. So we launch it on this exact scope with the supervisor job. We launch the children core, both children. So, but should we use it like this? Can we do something like this? Can we do it manually without this nice DSL? And yeah, let me switch. Yeah. Is it the same like that DSL or not? Or maybe I'm cheating and I added some tricks here. No? Of course I added. But maybe not in this case, maybe in another. Okay, first that came in your mind. 5, 4, 3, 2, 1, half, 1/3. Okay, that's enough. That's enough. Let's run. So actually, yes, it's the same thing. So we just unwrapped that nice DSL. This is how it looked like. We created the scope with the supervisor job, and we run on this job with this parent job. We launch 2 coroutines, and they can fail independently. And one more case for exceptions. No supervisor job. And here, but something changed here. But what changed, and how will it work? So we have a scope, and we launch 2 coroutines on this scope. And again, throw an exception. Will we have a lollipop here? Will we? Okay. And 5, 4, 3, 2, 1. Come on, come on, come on. Just something. Just pick something. Oh, come on, come on. That's enough. That's enough. Let's run it. No, but yes. So, yeah, we have a lollipop, but at the same time we have an exception. And what did just happen? And why we have a lollipop? And the reason why, because we have another job here. So the parent job is different. This coroutine has this parent job, and this coroutine has another parent job. On the schema, it looks like this. So we created some scope with the job, and we launch one coroutine on this scope with that parent job, and the second coroutine we launch on another job. It means the exception does not go to the parent job, because it goes, but there is another parent job. Yeah, this is it. This is all about exceptions, and the next batch of one case, just one case. Yeah. How will it work with timeouts? How many times it will be printed? Oh yeah. In this case, we need to count. And okay. Timeout 1.3 seconds. Loop 5 times with a delay in it. Okay, 5, 4, 3, 2, 1, and let's run. Yeah, we have an exception, and we don't have a check mark. Why? Yeah, because we use with timeout function, which throws an exception after the specified timeout. That's it. This is why. Yeah, thank you. Next case is async awaits. So what we have here is we launch two async functions which perform some task, with the delay and with the multiply. And we call await on both these tasks. And so actually there are two questions. What numbers will be printed? The easy question. And the hard question is, what time will it take? Okay, how much time will it take? 1 second? 2 seconds? Maybe more? Maybe it will throw an exception? Oh no, there is no this option. Initially, I wanted to add an option throws an exception to every case. But a little bit after, I forget to do it. I forgot it, yeah, so there is no this option. Okay, 5, 4, 3, 2, or 1. And let's launch. Pause here and launch here. Just 1 second. Yeah, why? Because the delay is a suspend function, and they run on the same thread, but since it's a suspend function, they can delay in the parallel. Yeah. You wanted to make a photo? Yeah, please. Yeah, we launch two coroutines, and they run in the they don't actually run. They just wait. They suspend, and we already know that when we suspend, the control goes back to the main thread, and it can launch any task. So that's it, and that's why it takes only 1 second. Okay, number of tasks with the time. And case number 1. We launch 3 coroutines. And we do some job in these coroutines. And in the end, we join all. And the main question is, will it throw an exception? If not, how much time will it take? Yeah, of course, there are a couple of main questions. Oh, okay, no main question. Just decide. How much time will it take? 2, 3, 4? How many seconds? Maybe infinite number of seconds and an exception in the end. Okay, 5, 4, 3, 2, and let's run. Pause here and run here. 3 seconds. As I said, there will be some tricks. Do you see this slip? What did just happen? you probably already know. Yeah. We launch first coroutine. It prints A and then it suspends. Delay is suspend function. The rest of the coroutine goes to the queue of tasks. Then we launch second coroutine. It successfully prints everything because because it does not suspend inside of it. It just interrupts the thread on 1 second, and it prints both. Then we launch the last coroutine, which prints E. Then it delays, and of course the rest of the coroutine goes to the task. And then we call join, and after join we have print time function, println function. And since join all it's a suspend function, we already know when we suspend, the control goes back to the thread, and it starts running from the queue of tasks and just prints everything else. Okay, be careful. What we've got here. We start, we have a loop, we do 10 times something. How much time will it take? Or will it throw an exception? And how I cheated this time? Okay, enough. Choose your option. 5, 4, 3, 2, 1, and yeah, pause here and run here. 1 second. Overall 1 second. Yeah, again, because we have a sleep here and we launch it here. Yeah. It's a sleep, so we interrupt the thread 10 times and we sleep 100 milliseconds, so overall it's around 1 second. And the last, here I changed something, added something, moved another, so what's gonna happen here? No sleep. Delay now, and the coroutine. One second, 100 milliseconds, exception, or infinite time. Okay, 5, 4, 3, 2, 1, and yeah, come on. Pause here and launch here. Again, just a second. Why? Yeah, because I moved launch from the bottom to the top, and it's apparent now. We just launch one coroutine and did a cycle inside this coroutine with a delay. We just delayed 10 times on 100 milliseconds. That's it. Enough with time, and we have something with the scheduler. So yeah, we have some function which we call heavy computation, and we launch 3 async functions, 3 asyncs, and we await them all. And the main question again: how much time will it take? It's a one thread scheduler, and yeah. What will happen here? How much time will it take? Three async. Heavy computation. But is it heavy? 5, 4, 3, 2, 1, and yeah, enough. Just 1 second. Overall 1 second. Why? Because, again, we already saw it somewhere. It's a delay, it's a suspend function, so they all can work in the parallel. And actually, it's a coroutine. It's a delay in the coroutine, so it's not so heavy. But how can we do it heavy? Is sleep heavy enough? It's not a task. It's just to run and check. Yeah, sleep is heavy enough. We also checked it. And let's go to the next. Next bunch, the last batch of problems, of tasks. So here, yeah, I need to show you what the counter is. Counter is just a task. It's just a data class with one field, which is integer field, and pretty is just prettifier of the number. And in the end, we do 2 loops, one inside another, and we do increment. We call increment function. So 1000 and the 1000 inside of it. And something with coroutines, and we have a 2-thread scheduler, and what will be the answer? And if we do something 1,000 times by 1,000 times, it should be 1,000,000. But will we have 1,000,000? I have a new main question. Will we have 1,000,000 here? Will we? With this sound, I'm trying to simulate a timer. Okay, will we have 1,000,000? 5, 4, 3, 2, 1. No, no million. We're close to the 1,000,000, but no. And why? First of all, we have 2 threads. and we're incrementing from 2 threads. And maybe you know, maybe not, but increment it's not an atomic operation. So inside, after compiler done, so it's done in multiple steps. And when we do it from 2 threads, they work in the parallel, they can take the old value, increment it, and then they both assign a new value which incremented already, and yeah. So it's a race condition. Okay, let's try with another thing. Now we have a synchronized block. Will it help us? Will we have 1,000,000? We have a synchronized block, but our increment got changed a little bit. Will it help? Will we have 1,000,000? If not, how much we will have? Okay, time to answer. We don't have much time, so yeah, let's be a little bit faster. 5, 4, 3, 2, 1. Yeah, it's just 1,000 with something. But why? First of all, we have a delay. So it's a suspend function. It means that there are a number of coroutines, 1,000 coroutines will work in the parallel and suspend somewhere in the middle, but they all take the old value and increment it just 1,000 times, maybe a little bit more. Next. And synchronize didn't help because we had a coroutines. Now, I removed it, no delay, all good. And we have a synchronized block. Will it help? Will we have 1,000,000? Will we? Okay, 5, 4, 3, 2, 1. Again, we close, but not close enough. Because, yeah, in the synchronized block, we just launch 1,000 coroutines inside the synchronized block. We don't do increment inside the synchronized block. Something wrong. Let's try use it properly. Now we use synchronized block, and inside this synchronized block, we launch increment. No tricks here. And so, everything should go well. Will we have 1,000,000 now? Did I cheat you? Five, 4, 3, 2, 1. Again, we're close to the 1,000,000. We're very, very close, but we don't have it. Because we synchronize on this. And this, in this case, is a coroutine scope. So we launch a coroutine, and this is a coroutine scope. And we have a 1,000 coroutines, and we synchronize it, so it doesn't work at all, because we don't synchronize. We just synchronize with a new synchronization primitive each time. And, 3 minutes more. Okay?
Speed up.
Yeah.
Just run everything immediately.
Yeah. So, will we have it here? Synchronize, bind counter, increment. 5. We don't have time at all. It's not you, it's because of me. 5, 4, 3, 2, 1, and yeah, we have 1 million. So we don't have time. Yeah, we have 1 million very, very fast. We don't have time, but you can. You can take it and you can play with it. Thank you.